Here's one more example. So here I've got a while loop with a and b as arguments to the function. As long as I is less than 256, I'm going to add a to the result, but each time I make a go smaller by b. So let's suppose you're given this code, you're given this bit of machine code, and you're told that this corresponds to getting a and getting b. And the problem here is to reconstruct the variables and the initial values for those variables as they relate to registers. So the question is, what does EAX mean? Well, in that case, it's given. EAX is given to mean a, and so its initial value is just the argument a coming into the function. We can't say anything more specific than that. Similarly, EBX, it was given that that corresponds to b, so its initial value is b. But now we have to figure out what ECX is for. And in the code here, we have an ECX XORed with ECX. But there's no, ECX is not initialized. Well, whatever value is in ECX, when you XOR it with itself, it's going to turn into 0, because every bit that's set in ECX is set in ECX. So those bits will cancel out, and where there's no bit in ECX, there's also no bit in ECX, and those will stay 0. So when you see XOR of the same register to itself, that's really initializing the register to 0. So ECX is getting registered initialized to 0. It looks like it's going to be I, right? And that's, in fact, as we go through and double check, that's what happens. And then what is this EDX? Well, it's getting the value of EAX, which is a initially. So that seems like a good candidate for result. So let's try that out and see if it's consistent with the rest. We have a L5 here that looks like the while loop. A while loop, we need to test whether I is less than 256 before we go in, right? But we can see that that first test will always be true because I is equal to 0. And the compiler can see this too. So the compiler sees that 0 is less than 256, so this initial test that it might put there, it just doesn't bother with. And that's why we move on to the loop right away. Then we put EAX and EDX. So that's A being put into EDX. So let's see. That looks like the result. Oh, it's being added to it, not moved. So yes, that's exactly like C code. Then we do a subtraction. EAX minus BX. Yep, that looks like the A minus equal B. We do an add of EBX. Again, B adding it to ECX, which is I. Yep, that matches up. We compare ECX to 255. ECX is I. That matches up, and so on. So, yep, we can see that we've correctly filled in this table here in blue.